Good morning, my dear students. A very warm welcome to today's science class. We are continuing the chapter force and pressure, and the topic which we are going to take up today is atmospheric pressure. But before that, let us look at what we have done in the previous class. In the previous class, we discussed about pressure, what is pressure, and then we also discussed about whether liquid exerts pressure or not. So, what is pressure? Pressure is the force acting on a unit area of a surface. The area over which the force is applied, for example, the pointed end of the nail, plays a very important role in making this task easier. Pressure is equal to force by area on which it acts. With this formula, you can find out the pressure exerted by an object on a particular area. Liquids also exerts pressure, and it exerts pressure in all direction in a container. So, after today's class, all of you will be able to compare atmospheric pressure and liquid pressure. In the previous class, we had discussed about liquid pressure, and today we will be discussing about atmospheric pressure. The keywords which we will be using are atmospheric pressure, air column, magnitude and pressure. Now, children, here is an activity which shows a rubber sucker. You might have seen a rubber sucker which sticks on surface and usually on smooth surface. So, children, what do you think? What helps it to stick? It is actually the pressure which helps it to stick, and which pressure? It is the atmospheric pressure. So, the atmospheric pressure helps the rubber sucker to stick on surfaces, and usually rubber sucker sticks well on smooth surfaces. So, let us now understand how atmospheric pressure helps in these activities. So, first let us understand what is atmosphere. Atmosphere is the air around us. So, you know that there are different layers of atmosphere. As you can see in the picture, the different layers of atmosphere are troposphere, stratosphere, mesosphere, ionosphere, and you will find that the atmosphere extends up to many kilometers above the surface of the earth. Like troposphere, from the surface of the earth, it extends up to say 10 to 14 kilometers, and then the stratosphere extends up to around 50 kilometers, and then it may extend up to around 200 to 300 kilometers from the surface of the earth. So, the air which is present around us is called the atmosphere, and the pressure exerted by this air on every object is known as atmospheric pressure. Now, let us understand what is atmospheric pressure in detail. You have already learned that pressure is force per unit area. Now, if we imagine a unit area and a very long cylinder standing on it filled with air, then the weight of the air in this cylinder is the atmospheric pressure. Now, let us take that the area which the cylinder is covering is unit area. Okay, it is unit area, and the air which is present inside the cylinder is exerting pressure on that particular unit area. So, the weight of that air which is present in the cylinder is called the atmospheric pressure. Let us now get an idea about the magnitude of the atmospheric pressure with this example. You might have seen rubber sucker. Take a good quality rubber sucker, and it looks like a small rubber cup. Press it hard on a smooth surface. Usually sticks very easily on smooth surface rather than rough surface. So, when you press the sucker, what happens is that the air which is inside will be forced outside. Yes, so it will move out, and as a result stick on the surface, then the air which is present inside will be forced out, and as a result the pressure inside will decrease. So, since the air inside has reduced, so the air which is around will begin to exert pressure from outside. As a result, it will stick very tightly to the surface. Now, it will not be easy to remove from the surface because the atmospheric pressure is very high. Now, if we want to remove, then we have to pull with a force which is greater than atmospheric pressure. So, now you can imagine that how large is the force of atmospheric pressure. In fact, we can say that it would not be possible for any human being to pull the sucker off the surface if there were no air at all between the sucker and the surface. I had mentioned that atmospheric pressure is being exerted on all objects. Then why do we not feel the pressure? Actually, we cannot feel the atmospheric pressure because our body is also filled with air. The pressure inside lungs, blood vessels and several organs apply the same pressure from inside as the atmospheric pressure is applied on our body from outside. So, it balances the pressure. As a result, we do not feel the pressure. Now, let us take one more example where we experience atmospheric pressure. So, we had already discussed about the rubber sucker. Now, let us discuss about the drinking straw. So, when you go to restaurants and you order juice, you are served in a glass with a straw. Now, how does the liquid gets inside the straw? So, when you suck the air out of the straw, that means the pressure inside the straw decreases because the air has been removed and the atmospheric pressure begins to act on the surface of the liquid. So, since it acts on the surface of the liquid and the atmospheric pressure is now greater than the pressure inside the straw, there is a difference in the pressure created. So, as the atmospheric pressure exerts force on the surface of the liquid tends to move into the straw when you suck the juice. Yes, and this is how you are able to drink juice or say water or any type of liquid using straw. And here what is the principal use? It is the principle of difference in the pressure inside the straw and outside. Now, how much is the atmospheric pressure exerted? So, we will take the reference point as sea level. So, at sea level the value of atmospheric pressure is 1.01 into 10 to power of 5 Pascal. So, Pascal is the unit of pressure. So, at higher or lower altitude the atmospheric pressure changes. It may increase or decrease. As the value changes with altitude, the reference value is taken at sea level. There is an instrument called mercury barometer which is used to measure atmospheric pressure. The SI unit of atmospheric pressure is Pascal. Also, another unit called atmosphere is used, like the value of atmospheric pressure at sea level is 1.01 into 10 to power of 5 Pascal, which is equal to 1 atmosphere. So, both the units are used for measuring atmospheric pressure. Now, this is an interesting fact you might not know. Otto von Guericke, a German scientist of 17th century, invented a pump to extract air out of the vessel. With the help of this pump, he demonstrated drastically the force of the air pressure. He joined two metallic hemispheres of 51 centimeter diameter each and pumped air out of that. All the air was removed from those hemispheres. Then it was sticked to each other. He then employed 8 horses on each hemisphere to pull them apart, but it could not be pulled apart. So, you can imagine that the force of air pressure is so great that the hemisphere could not be pulled apart even after employing 8 horses to pull each hemisphere. So, this great is the force of atmospheric pressure. So, related to this topic what we have discussed, I had given 2 questions. Children, I want all of you to try to answer these questions. Question number 1, we know that there is huge amount of atmospheric pressure on us, but we do not experience its effect. Why? So, children, we have already discussed this question. Try to write down the answer to this question in your copy. The second question is, here is a picture given. So, you need to analyze the picture, and you might have done this activity also. So, why does the cardboard do not fall even when hand is removed? You can see that in the picture, the cardboard is placed on the glass and the glass is inverted and then the hand is slowly removed. So, why is it so that the cardboard does not falls off when it is inverted? So, children, I am sure that you will be able to answer this question also. So, try to write down the answer to this question in your copy. Today's homework is Me and Mind worksheet number 78. So, this is all for today's class. Now, let us summarize what we have learned in today's class. In today's class, we had learned that the pressure exerted by air is known as atmospheric pressure. Pressure is force per unit area. If we imagine a unit area and a long cylinder standing on it filled with air, then the weight of the air in this cylinder is the atmospheric pressure. As the value changes with altitude, the reference value is taken as sea level. It is measured by an instrument called mercury barometer. SI unit of atmospheric pressure is Pascal. Another unit is also used, which is atmosphere. So, 1 atmosphere is equal to 1.01 into 10 to the power of 5 Pascal. So, I hope that all of you have understood about the topic which we had discussed today. Thank you and have a great day ahead.